Hello everybody and welcome back. We're continuing our look at the 2006 Galois paper. So that is a grade 10 level contest. And we are on question number 2. In the diagram, A, B, B, C, C, D, D, E, E, F, F, G, G, H, H, K all have length 4, and all angles are right angles, with the exception of the angles at D and F. And if D, E, and EF are 4, I think that's going to force these guys to be 45 degrees. Just a quick observation. It's a written solution contest, so we'll have to back that up if we ever need it, but pretty sure those will be 45s. Even just due to the massive symmetry here. So we've got, 4 parts here. A, determine the length DF. That doesn't seem so bad. We'll draw our picture, and then we'll talk about DF. But DF, we can quite easily see, is the hypotenuse of DEF, because we got a right angle here. So we can use Pythagoras, because we know each of the lengths. We'll put the letters back in, so it's D, F, E is in the middle, A is down here, A, B, C, D, E, F, G, H, and then they jump straight to K. I think mathematicians try and avoid I and J because they can look quite similar to 1s, but I really don't know why they don't have I and J. Anyways, so let's explain. We see triangle DEF is a right triangle, and DF is the hypotenuse. So DF squared is DE squared plus EF squared, but both of those are 4. So it's going to be 16 plus 16, or 32. So DF is square root of 32, which I'm choosing to rewrite as 4 root 2. Well, there we go. Not that hard. Notice that now we have DF. We can actually figure out length AK. I don't know if this is going to end up being the next question, but I'll just talk briefly about it. These are the sorts of connections I start making in my head. Oh, I figured out one thing. What else could I figure out? But we drop these perpendiculars down here. We see, and we could even call them I and J, because they have neglected to create an I and a J. But we can see DFIJ, or DFJI, is a rectangle, so this length here is also going to be 4 root 2, and we've got some squares here, so these will also be 4s. Just little observations. I have no idea if this is going to be B part. Okay. Actually, looking ahead, we never have to calculate AK exactly. The closest we get is what is the area of this figure, and we'll talk about that when we get to it. But let's look at B part now. If perpendicular EM is drawn from E to DF, what is the length of EM? Explain how you got your answer. Okay, well, again, I think we really just, it has nothing to do with the larger figure, it's just DEF, and it's a right angle triangle, and DE is EF, so each of those are going to both be 4. Yeah, we'll just hypotenuse again. So let's just jump into it. Okay, so we're just looking at DEF. I'll make that a little bigger. Another thought I just had, having looked ahead at D part, which says we need to get the area of the whole thing. If I can do this by area, and I think that might be a cleaner way to calculate it. So I'm going to say, notice EM is an altitude, So the area of DEF is 1/2 base DF, which we just calculated, times height, which is EM. But this area is also equal to 1/2 DE times EF. And that's since DE and EF were perpendicular, they are also we can consider one of them a base and one of them a height. So this area is 1/2 4 times 4, which is 8. So I know 1/2 DF times EM is 8. This is 1/2 4 root 2 times EM. 8 is 1/2 times 4 is 2. So 8 is 2 root 2 times EM. And if I rearrange, EM is 2 root 2. Not a whole lot that needs to be explained there. We just calculated the area of DEF in 2 different ways. And if you wanted to, of course, add in a sentence explaining, that's what we're planning on doing. But using that, we can calculate length EM is 2 root 2 quite quickly. You could have also, it's not that hard to see. We'll just very quickly talk about it. Since it's an isosceles right angle triangle, these angles are going to both be the same, the D and the F ones. They're going to have to add up to the remaining 90 degrees, so we get 45s here. And then, well, look at this smaller purple triangle. It's right angled. 145, we get another 45. So we can realize that this is X and this is X. So the length of EM is just going to be, and this one's also X, length of EM is just going to be 1/2 DF. That'd be another way to do it. And check, yeah, it really is 1/2 of DF. So certainly more than one way to do B part. And let's jump into C part now. If perpendicular EP is drawn from E to a K, what is the length of EP? Explain how I got my answer. Okay, this shouldn't be too difficult. We'll switch it off of purple for a moment and we'll redraw our figure. What I'm going to do is I'm going to recognize length EP as a difference in 2 lengths, one of which I just learned in the last part. So, E to P, we'll put P here, E here, and then we'll let purple be M, so we get right angles. And we've got D, F, G, H, K, A, B, C. Okay. So, notice that MP is a line through E. And notice that it's a height of the quadrilateral. There we go. Now we can calculate the height of this quadrilateral pretty quickly because we know each of these lengths here is 4. So FG plus HK equals 8, which is the height of the quadrilateral. So now I know the total height here is 8. If you wanted to, if you felt like that wasn't a good enough explanation, you can, of course, extend HK up, get a right angle. This is a square, so this is the same length, and so on. That's fine. I don't think that's necessary. So we recognize the height of the quadrilateral, and we say something like, from B, ME is 2 root 2. 8 is equal to ME plus EP, so that's 2 root 2 plus EP. Rearranging, we get EP is 8 minus 2 root 2. You can write that other ways, 2 times 4 minus root 2, that would be perfectly acceptable as well. But the point is we have the length EP. Okay, and I already peeked ahead at D when I was trying to mess around with the question a little bit. What is the area of A, B, C, D, E, F, G, H, K? Explain how you got your answer. Alright, so I'm going to redraw the picture. There's lots of ways I think we can do this. The easiest way, I think, is either to enclose it in a giant rectangle, which I will do with the dark blue. The giant rectangle, we know side length is 8. If we figure out what the length of AK is, which is something that I've mentioned I know how to do, then we can have the area of the big rectangle, take off this tiny square, side length 4 and 4, take off this square, 4 and 4, and take off the 8 for this triangle. That would be a fine way to do it. Other ways we could do it, and it's all along the same theme of recognizing shapes that are easy to calculate. Things like squares, things like circles, things like right-angled triangles. So another thing I think we can do, and I'll use the light blue to illustrate it. The light blue, there we go. Another thing I think we could do is chop it up into, we got a square over here, it's 4 by 4. And then we got another 4 by 4 here. And then we have this rectangle here, which I know is 4 root 2 by 8. And then take off this little triangle here. Still yet a third way you could choose to do it. And then I'll do the middle one because that's the one that I really thought of first. Still another way you could choose to do it. We just learned what EP is. So we could make that the height of this rectangle here. And then we have two little triangles, and we know that they're going to have 45s here. So we get two little triangles, and we could add those together in some way. There's probably more ways we can chop it up. I'm going to choose to do the middle one. So, I've got to explain what I'm doing at each step. So, I'll draw my full picture again. Okay, and we got A, B, C, D, E, F, G, H, K. I'm going to say get perpendiculars here. So let's explain where these come from. We'll call them I and J. From C and to G, drop perpendicular lines to I and J on the length AK. Okay. Notice, and then I'm also going to add in DF up here. Notice that by all these right angles, ABCI, IDFJ, and GHKJ are rectangles. Okay, we see that the area of A, B, C, D, E, F, G, H, K is ABCI plus IDFJ minus DEF plus GHKJ. So this is a 4 by 4. This one here is a 4 by 4. This is 8. The height was noted in C. Times 4 root 2 DF that we figured out in A minus 8. And we found that out when we were calculating things in B. So we get 16 plus 32 root 2 minus 8 plus 16. And the 2 16s is 32 minus an 8 is 24. So 24 plus 32 root 2. And that's what I'm saying is our final area. Okay. Not a whole lot we need to. If you wanted an intermediate step where you actually broke this down into AB times BC and just showing where these lengths are coming from, that would be perfectly fine. But I don't think that's entirely necessary. Do explain where these, like the 4s, I don't think need an explanation, but do explain that, yeah, we already noted the 8 and C part. And yes, we already solved for the DF in the first question. Just recalling those things, just saying, you know, this came from B, this came from A, it shows that you are making the appropriate connections. That in D part we have to explain, but no sense in re-explaining something I've already explained in A part or already explained in C part. Okay? But that finishes off question number 2, which means we are halfway done the 2006 Galois. Our eyes then turn to question number 3, which we will take care of in the next video. Thanks for watching. I'll see you next time.